Hey everybody, this is Andy Melbuff, and in this video we're going to take a look at using computation layer in Decimal's Activity Builder to allow teachers to expand the types of feedback they give to students. That feedback can be instructive or corrective and can rely on some common misconceptions and common incorrect responses that students make, and we're going to take a look at several examples of those right here. Now I'm going to take you into an activity I have set up already, and one of the first ways we can do this, and this is more of a elementary type of version where students are rounding incorrectly. And so we can set up feedback based upon certain ways that they round. Now, if we ask students to round 8/12 into a decimal and we want it rounded to the nearest hundredth, a correct response would be 0.67. And you can see here in the dashboard, I've set this up so that the activity builder grades it as correct for the teacher's viewing. And when the submit button is pressed by the student, they get a piece of feedback right here for a correct answer. Well, how about an incorrect answer? So a common misconception would be for students to get the correct decimal place, but not round up because of the 6 value there. So if they were to submit 0.66, there's an X showing in the teacher dashboard. When they press submit, they get a very specific piece of feedback based upon that one wrong answer. Another misconception might be if they type in 0.7 and they press submit, they'll get a different piece of feedback. So we can build that feedback to incorporate as many types of incorrect responses as desired. So let's go ahead and take a look at how we do that. So I'm going to take you into a second screen here that's got basically a duplicate of the one I was just on, but I've left out a lot of the computation layer. So I'm going to first go into the input, and this component is labeled input, and I'm going to set my correct check. My correct check comes from the sync that is teal colored. And what component am I going to use? I'm going to use, well, I don't need to name it because I'm in this component. So I'm going to use this numeric value, and I want that to be equal to 0.67. Now watch what happens when I type 0.67. I get an error message here. We need to have any decimal value start with a placeholder in front of the decimal. So we just put a 0 in front and that little warning message goes away. So now my correct check is set, but I also want to set up feedback. So I use the word feedback for my variable here, and I'm going to use conditions. When input is a numeric value, keep missing that number there we go, equal to 0.67, and the student has submitted it. I like them to commit to submitting. Then I'm going to have a specific message. I'm just going to type great job here. You can add emojis, text, whatever you'd like, and I'm going to enclose that message in quotation marks. Now I can put different messages in for different types of input by the student, and I just keep going with a similar format. So if they were to type in a numeric value equal to 0.7 and they submit it, I like them to commit to that. You can have a different message. You can make that message as expansive or simple as you'd like. And I'm just going to show you the feedback I put for the example we just looked at. Let's see, we had 0.66. I'm not being very helpful here with this, meaning I'm just trying to speed this along, I would put some more meaningful feedback in here for students. Now, when I finish with whatever conditions I have in there, I always have to finish with otherwise. And I want to have otherwise, I'm just going to put no feedback in there. So what I'm leaving out is feedback for incorrect answers other than these right here, but this is now ready to go. I can insert this feedback into my note. You can preview it, and I'll just show you quickly those. Here's the correct response, one piece of feedback. Here's one of the incorrect responses, a different piece of feedback. Here's the other type of incorrect response for feedback. Now, if the student types in something like 0.9, there's no feedback there. I haven't set that up for that. So that's one way to incorporate corrective feedback. Here's a second example, and this is more of an algebra high school level type of situation where students are asked to simplify a rational expression. Now, what I see commonly, this is the most common case right here, students will look at this and they'll go, oh, those are the same. We're going to cancel those out, and they'll type in 5x plus 6 over 4x plus 3. So let me clear that out. And if students type in that result, you can see it's wrong in the teacher dashboard. When they press submit, they get a specific piece of feedback based upon canceling those x squared terms, which they're not allowed to do. If they were to factor correctly and then cancel, let's see, that would be an x plus 2. The denominator would be an x plus 1. Submit, then they get a different piece of feedback. The correct check you see is working there. So how do we go ahead and build this? So I've got a duplicate screen here with the same note, same input. The input is titled input. I know, pretty fancy. I'm going to go ahead and build this part first. Now, I want to show you a slightly different version that sometimes is more user-friendly, and that's you can make variables in here and carry them over into the note. So I want to start with a correct variable. Now, it's not the sync, so I'm going to put an equal sign after it. Now, I want my correct response to be from this component, and I want to pull the LaTeX. It's not a numeric value, it's a LaTeX. It's basically mathematical expression. And I need to use parentheses, and what I'm going to enclose in there, I want mathematical, so I enclose that in backticks. And here's where a little LaTeX comes in for you. If you're familiar with it, great. If not, you might want to avoid this type of situation. I want to create a fraction. So a fraction uses a backspace, and then I want frac, and then I use curly brackets for the numerator and denominator. Lastly, I'll enclose my last backtick, and then a parentheses. Now, what do I want my numerator to be for a correct answer? I wanted an x plus, I can't remember now. I wanted an x plus 2. So I want an x plus 2 in my numerator, and I want an x plus 1 in my denominator. So this will now generate a correct response. Everything looks good there. Curly brackets, parentheses. Okay. Then I want to have an incorrect variable. This LaTeX. Oh, I know what I'm missing. I probably need an equal sign in here. There we go. That's why that little warning label is there. I'm going to do the same type of format inside of my parentheses because I want math notation. I'm going to use 2 backticks, so I'll put them in first. And between those backticks, I want a fraction. LaTeX uses frac, and then I use curly brackets. And a common misconception would be the students have 5x plus 6 or 4x plus 3. So that's going to be an incorrect response that's pretty common for students. And basically, I'm going to tie this into the note in just a moment. Now, I still want to set my correct sync here. And I'm going to attach it to the word correct since I've already made that variable. I won't have to type all this again. So my dashboard will look for is what's in the correct variable showing when the students input. Now, let's go into the note. For my feedback variable, I start with when. Now, so I don't have to type all that LaTeX notation again. I want to draw the variable that I created, the correct and incorrect, into this. So when my input component, and I use script basically says look for a variable after that. And then here are my choices of variables. So here are the variables that I've used in the input component. I'm going to choose correct. So when that happens and input is submitted, I can have a feedback message. And when my input script is incorrect, I can have a different feedback message. If I want to put x squared in here, use backticks again. I'm just going to show the message up. And I can also have when input is submitted. Basically, it's an incorrect answer, but it's not the common one. I can have a third message. For example, otherwise, nothing shows up. So my feedback variable set, warning labels are gone. I want to insert that into my note using this little button right here. Feedback, let's try it out. I'm hoping this works. So if a student enters the correct response, the fraction x plus 2 over x plus 1, dashboard check works. Submit, feedback, nice work. If they type in, let's see, it was 5x plus 6 over 4x plus 3. See, it's wrong up here in the dashboard check. Upon submitting, they get this very specific piece of feedback that you can't cancel those x squared terms. And notice, because I put the x squared in backticks, how mathematically nice it looks right there. And if a student enters a wrong answer that's not one of those special ones I created, they just get that general piece of feedback right there. So that's a little bit more sophisticated, but it again shows how we can offer specific types of feedback based upon student responses. The third type of feedback we're going to look at is a situation where students might have to expand an expression. And because this involves some algebraic notation, we can't use variables for numeric amounts anymore. So we're going to take a look at what function evaluation can provide for us here. So a correct response would be students typing in x squared plus 7x plus 12. The dashboard check is working. Upon pressing submit, they get a piece of feedback. If they type in something incorrect, then they get some corrective feedback. Well, what we have to account for is the fact that students will oftentimes put extra spaces and stuff in the front of their responses. Let me give you an example. X squared plus 7x plus 12 is the correct response. But we as teachers, don't we see this a lot? An extra space in front of the 12, it's still being marked correct. How about an extra space in front of the 7? Still correct. How about several extra spaces? As long as this is mathematically correct, we're in good shape, but we need to evaluate it. We can't just use the LaTeX that we used in the previous one, because LaTeX is very specific. You have to have exactly what's set to your variable. So we can account for that here by using function evaluation. So here we're looking at duplicate screen, same note, same input, but I've taken a lot of the CL out and we'll go ahead and build this. So I'm going to start with the input, and I'm going to use, again, a correct variable and an incorrect variable, but those haven't been set yet. I'm going to first create a function to help us with our evaluation. And I'm just going to label it f equals. So this is a variable I'm creating, and I'm going to make it a simple function. And I want it to be with which component? This component, and I want to pull the LaTeX from it. So what this will do is whatever the student types in the input box, the LaTeX will become function f. And then to set my correct variable, what I'm going to do is use that function to evaluate. So here's how this looks. F dot evaluate at. And I'm going to choose several values. Now we desire an expansion to be x squared plus 7x plus 12. So the way this evaluation works is we're going to pick several convenient values for x and substitute that in. So one convenient value I like to use is 0. If I were to substitute 0 into x squared plus 7x plus 12, my result is going to be 12. So I'm going to evaluate what the student types in to see if when 0 is inputted, 12 is outputted. But I need to do several as well. We typically use 3 at a time. And so we're going to repeat this process with different inputs. What if we were to substitute 1 in for x? If I put 1 into x squared plus 7x plus 12, we're going to get, 20. And a third point, I'm going to do the same type of thing, and I'm going to evaluate at a value of 2. 2 squared is 4, and 14 is 18, and 12 is 30. This should be an output of 30. So what I'm doing is I'm setting a variable to evaluate correct when the student's input is evaluated at 3 different points, 0, 1, and 2. And if that occurs, that's great. That's what we're looking for. Now, I have to also have incorrect. So I'm not going to be very specific here. I'm just going to make my incorrect variable be anything other than what the correct variable is. So I'm going to use not the variable correct. I'm going to set my correct sync to be equal to the correct variable. And I don't know if that bothers some of you having the same word there. But now my warning symbol goes away and this is all set to go. So what I want to do is then pull both of these, correct and incorrect, into my feedback using script. So I'm going to jump into my note. Oh, I already had that started in there. Okay, this is similar to what we did in the previous one. When the input script is the variable correct and it's been submitted, here's the feedback I am showing here. But what I also want to do is define the function in here as well. I do it just like I did earlier, and I believe we should be good to go. Let's check this out. Preview mode. If the student types in the correct response, x squared plus 7x plus 12, the check is correct there. You know what I neglected? I didn't put the feedback variable in the note. Common mistake for me. Let's check it again. There's some feedback, and if the student types in anything other than the correct response, here's the feedback they receive on that. The correct check shows an incorrect answer. So this is how we can be a little more sophisticated, checking algebraic expressions, and it accounts for the students, doing things like putting in spaces here. You can see they can put in a whole bunch of spaces and there's still going to be a check mark there. Or they can have a time symbol between the 7 and the x, and it's still going to be evaluated as correct because this input, this LaTeX, has been checked in the function at 3 different places. Okay, thanks for watching.